Hi Mr. JC and classmates, today I'm going to be showing you guys how to solve my vector problem algebraically. So first, the instructions say vector A has a magnitude of 16.6 units at an angle of 32.7 degrees. Vector B has a magnitude of 13.3 units at an angle of negative 77 degrees. So I already took the liberty of pointing out that A has 16.6 units with 32.7 degrees and vector B has 13.3 units with an angle of negative 77 degrees. So I already drew both graphs. So for vector A, as you can see, it travels 16.6 units and has an angle of 32.7 degrees, and it has an AY pointing upwards, meaning it's positive, and AX pointing to the right, meaning it's positive also. And as you can see, it's located in the first quadrant. And then for the second vector, you can see it's pointing downwards because it has the negative degrees, which is negative 77, and it's located in the fourth quadrant. And as you can see, BX is pointing towards the right, meaning it's positive, but BY is pointing downwards, meaning it's negative. So BX is positive and BY is negative. So let's start. First, we will use the following formulas to find the values of AX, BX, AY, and BY. So first, for AX, we will have the units which it travels, which is 16.6 times the cosine of 32.7 degrees, which will give us 16.6 times the cosine of 32.7, which gives us 13.97. So AX is 13.97. Now we will find AY. Again, 16.6, but this time we will multiply it times the sine of 32.7 degrees, and this gives us approximately 16.6 times the sine of 32.7, which gives us 8.97. Now we will do for vector B. So BX will be, since this one's 13.3 times the cosine of negative 77 degrees. We will calculate this now, and times cosine of negative 77, which gives us 2.99. So we will write down 2.99. Now BY, remember BY is negative, so at the end, whichever answer we get, it will have to be negative. If it's already negative, it will stay negative, but if it's positive, it will turn into a negative. So we will multiply 13.3 times the sine of negative 77 degrees. And this will give us, 13.3 times the sine of negative 77, which gives us approximately negative 12.96. Negative 12.96. So now we already have all the values. So now we will find the magnitude of the resultant vector. And we will use the following formula, which is Rx. To find Rx, we will use first Rx equals AX plus BX, which will be 13.97, which is AX, plus BX, which is 2.99. So we will now calculate this. 13.97 plus 2.99, and we get approximately 16.96. So we will write down that Rx is equal to 16.96, and now we already have Rx, and now we will want to find Ry. And to find Ry, we will use the following formula, which is the same as Rx, but we will use AY plus BY. So we will use 8.97 plus negative 12.96, and we will calculate this in our calculator. And for this one, it's most recommended you put the parentheses, since we're dealing with the negative numbers, so we don't want to get the wrong calculation. So we will use the parentheses, 12.96, which gives us negative 3.99. So now we already calculated the magnitude of the components, and now we can find the resultant vector value. So since we're gonna draw a small graph here to represent the resultant vector. So it doesn't have to be a good graph like the others. It's just to see like the resultant vector and to get an idea of where it is. So we're gonna draw it. We know it's supposed to get us 17.5, so it will be going downward, and since it's in a negative degrees, so it will be pointing downwards, and it should get us negative 13.2 degrees. And so our y should be negative, Rx positive. And so yes, so first, as I said, we will find the value of the resultant vector, and then finally we will find the value of the missing angle. So first, now that we have both components Rx and Ry, we can now calculate the resultant vector. So we will use, since this is right, we can approximate that this is a right triangle. We can use the Pythagorean theorem, but we will use the modified version, which is Rx squared plus Ry squared equals R squared. So we plug in the numbers. We got Rx is 16.96 squared plus Ry, which is negative 3.99 squared equals R squared. So now we will calculate the addition first, which is 16.96 squared plus negative 3.99 squared, and we should get approximately 303.56. So we write down the 303.56 equals R squared, and now we have this. Now we will want to find the value of R. So we will have to cancel the exponent by using a square root. So we will square root this too, and so we will now put in the calculator. You can put in a square root of 303.56, but an easier way is you just put the square root symbol and put answer, and we should get 17.42. 17.42, and as I mentioned, graphically in the FET simulation we got 17.5, so it's a very close approximation, it's correct. So we got 17.42 algebraically, and in the FET simulation it's 17.5, so the difference is very close. And finally, in the FET simulation, the angle is negative 13.2 degrees. And now we will calculate the angle. We will calculate the angle to see if we get the angle also. So for the angle, turn the page. So for the angle, we will use the following formula, in which we will use a tangent inverse. So to find the missing angle, so the following formula is theta equals tangent inverse times the absolute value of Ry divided by the absolute value of Rx. So now we plug in the values. So we said we got for Ry it's negative 3.99, but since it's an absolute value, it must be just 3.99 divided by Rx, which we got 16.96. So it's divided by 16.96. So we do this calculation now. We will remember tangent inverse. You have to first press shift, then tangent. Sorry, wait. Here we go. And then in the parentheses, we insert the values, which are 3.99 divided by 16.96. And we get approximately 13.2 degrees. And remember, since the resultant vector is looking downwards, the angle must be negative. So it will be negative 13.2 degrees. And as we got in the FET simulator, we got negative 13.2 degrees, and here we got negative 13.2 degrees. And finally, we have to describe if it's above or below the x-axis, and if it's above the positive x-axis or above the negative x-axis. So our answer would be negative 13.2 degrees. 13.2 degrees is below, as you can see here again, looking at the graph, you can see it's below the x-axis and it's below the positive x-axis, because here's the positive x-axis, so it's below the x-axis, below the positive x-axis. So our final answer would be negative 13.2 degrees is below the positive, you can just write this positive symbol, x-axis, and this would be our final answer. So as you can see, to recap, we first found all of the components, then we found the components to find the resultant vector, then we found the resultant vector, which we got 17.42, and the resultant vector in the FET simulator was 17.5, so it's basically the same. And finally, we found the missing angle, which we got negative 13.2 degrees, and in the FET simulator it's the same, which is also negative 13.2 degrees, and our final answer, which is negative 13.2 degrees, is below the positive x-axis. So I hope you learned from this experience, and I hope you enjoyed. Thank you.